Buenas noches, amigos conspiranoicos. Hoy vamos a hablaros de nuestra estrella favorita, KIC 8.462.852, o más comúnmente conocida como la estrella Tabby. Tabby se encuentra en la Vía Láctea, a unos 1500 años luz de la Tierra, entre las constelaciones de Cygnus y Lira. Fue descubierta en el año 2009, aunque se hizo famosa a partir del año 2015, a raíz de las observaciones de un equipo de astrónomos de la Universidad de Yale. Es una peculiaridad única hasta el momento, y los científicos todavía no han dado una explicación plausible. La falta de datos y la lejanía de la estrella dificultan mucho su estudio en profundidad. Estos científicos descubrieron un extraño patrón en la luz que rodea a la estrella. Los datos que nos ofrece el telescopio Kepler muestran que el brillo de la estrella varía de forma irregular y muy acusada, lo que, según los expertos, no puede explicarse solo por un sistema planetario orbitando a su alrededor. Las variaciones de luz en Tabby son de hasta un 22% y de forma no periódica, cuando lo normal, si hubiera un planeta orbitando alrededor de la estrella, es que fueran, como mucho, del 1 al 3%, y además de forma cíclica o periódica.
Y ahora vamos a escuchar una explicación de la jefa del equipo de investigadores que descubrió la anomalía, de quien hereda el nombre de Tabby.
Extraordinary claims require extraordinary evidence. And it is my job, my responsibility as an astronomer, to remind people that alien hypotheses should always be a last resort. Now, I want to tell you a story about that. It involves data from a NASA mission, ordinary people, and one of the most extraordinary stars in our galaxy. We began in 2009 with the launch of NASA's Kepler mission. Kepler's main scientific objective was to find planets outside of our solar system. It did this by staring at a single field in the sky, this one with all the tiny boxes. And in this one field, it monitored the brightness of over 150,000 stars continuously for 4 years, taking a data point every 30 minutes. It was looking for what astronomers call a transit. This is when the planet's orbit is aligned in our line of sight, just so that the planet crosses in front of a star. And when this happens, it blocks out a tiny bit of starlight, which you can see as a dip in this curve. At the same time of the first data release, astronomers at Yale were wondering an interesting thing. What if computers miss something? And so we launched the citizen science project called Planet Hunters, to have people look at the same data. The human brain has an amazing ability for pattern recognition, sometimes even better than a computer. However, there was a lot of skepticism around this. My colleague, Deborah Fisher, founder of the Planet Hunters project, said that people at the time were saying, "You're crazy. There's no way that a computer will miss a signal." And so it was on, the classic human versus machine gamble. And if we found one planet, we would be thrilled. When I joined the team 4 years ago, we had already found a couple. And today, with the help of over 300,000 science enthusiasts, we have found dozens. And we've also found one of the most mysterious stars in our galaxy. So to understand this, let me show you what a normal transit in Kepler data looks like. On this graph, on the left-hand side, you have the amount of light, and on the bottom is time. The white line is the light just from the star, what astronomers call a light curve. Now, when a planet transits a star, it blocks out a little bit of this light, and the depth of this transit reflects the size of the object itself. And so, for example, let's take Jupiter. Planets don't get much bigger than Jupiter. Jupiter will make a 1% drop in a star's brightness. Earth, on the other hand, is 11 times smaller than Jupiter, and signal is barely visible in the data. So back to our mystery. A few years ago, Planet Hunters were sifting through data looking for transits, and they spotted a mysterious signal coming from the star KIC 8462852. The observations in May of 2009 were the first they spotted, and they started talking about this in the discussion forums. They said an object like Jupiter will make a drop like this in the star's light, but they were also saying it was giant. You see, transits normally only last for a few hours, and this one lasted for almost a week. They were also saying that it looks asymmetric, meaning that instead of the clean U-shaped dip that we saw with Jupiter, it had this strange slope that you can see on the left side. This seemed to indicate that whatever was getting in the way and blocking the starlight was not circular like a planet. There are a few more dips that happened, but for a couple of years, it was pretty quiet. And then in March of 2011, we see this. The star's light drops by a whole 15%. And this is huge compared to a planet, which would only make a 1% drop. And again, after this, not much happens. Until February of 2013, things just start to get really crazy. There is a huge complex of dips in the light curve that appear, and they last for like 100 days, all the way up into the Kepler mission's end. These dips have variable shapes. Some are very sharp and some are broad, and they also have variable durations. Some last just for a day or two, and some for more than a week. And there's also up and down trends within some of these dips, almost like several independent events were superimposed on top of each other. And at this time, the star drops in its brightness over 20%. This means that whatever is blocking its light has an area of over 1,000 times the area of our planet Earth. And so when the science team looked at it, we're like, yeah, there's probably just something wrong with the data. But we looked really, really, really hard, and the data were good. First, somebody said, well, you know, what if this star was actually very young and it still had the cloud of material it was born from surrounding it? And then somebody else said, well, what if the star had already formed planets and two of these planets had collided, similar to the Earth-Moon forming event? And so we went ahead and published our findings. Now let me tell you, this was one of the hardest papers I ever wrote. Scientists are meant to publish results, and this situation was far from that.
Son varias las hipótesis propuestas para explicar los extraños comportamientos de Tabby. Una de estas hipótesis es la afluencia o colisión de un grupo de cometas alrededor de la estrella. Esta teoría ha perdido fuerza últimamente, ya que en los últimos días la estrella ha perdido tanto su fulgor que parece imposible que sea debido exclusivamente a una lluvia de cometas. Otra de las hipótesis planteadas por el equipo de investigación es que estas irregularidades fueran producidas por una colisión planetaria. El oscurecimiento gravitacional también se ha valorado como teoría que explicaría el fenómeno. Esto ocurre cuando una estrella tiene forma irregular y la gravedad afecta de manera diferente en el ecuador y en los polos. Cuando un planeta orbita alrededor de una estrella con gravedad irregular, puede ocurrir que los patrones de luz que nosotros recibamos de esa estrella sean igualmente irregulares, tal y como se observan las emisiones irregulares de luz de Tabby. Pero definitivamente, la hipótesis que más nos gusta es la de la megaestructura alienígena. Varios autores hipotetizan que las irregularidades en la emisión de luz de Tabby pudieran deberse a que tiene una estructura similar a la propuesta en los años 60 por Dyson, la llamada esfera de Dyson. Esta megaestructura hipotética, creada por civilizaciones alienígenas avanzadas, consistiría en un recubrimiento o envoltura de una estrella para obtener energía fácilmente. Los científicos parece que no se ponen de acuerdo y han desestimado todas las hipótesis. Así que nosotros hemos creado nuestra propia hipótesis. En el Palacio interior creemos que las asimetrías en el fulgor de la estrella Tabby no son ni más ni menos que el resultado de una guerra interestelar, igual que en la Guerra de las Galaxias. Pensamos que hay dos civilizaciones en lucha por el control del sistema Tabby y las irregularidades registradas por el Kepler no son más que el resultado de explosiones, sabotajes y contiendas entre dos civilizaciones alienígenas. A nuestro juicio, esta es la única explicación que tiene sentido. Solo esperamos que los perdedores no se fijen en la Tierra como próximo y más sencillo objetivo. Queremos que vengan los alienígenas, amigos, pero siempre que vengan en son de paz.